Right. Hello everyone, James here. Today we'll be discussing a past paper from 9709, paper 4 mechanics, in preparation for the time trial tomorrow. Alright, so this is the paper that we'll be discussing. It's the October-November 2025 paper 45. If you want, you can try the paper yourself. The question paper is in the pinned comment of the video. Right. So let's begin with question 1. This is a very classic kind of question to resolve a system of forces in equilibrium. To solve this kind of question, what we will need to do is to resolve each of the forces into their separate components. So here we want to resolve all the forces horizontally and vertically. Based on the line of action on the point where they act, to find the magnitudes of P and Q. Right. Resolving horizontally, we can observe that, say we have horizontally, let's say this is positive, let's say this direction is positive and this direction is negative. Then horizontally we can resolve all 4 of the forces to obtain that. 32 cos 35 plus Q cos 65 equals to E plus 21 cos 47. Well, first things first, you should note that all of the forces have the angles in degrees. So when you want to solve this, you should ensure that you are calculating your trigonometric values based on degrees, not radians. Resolving the same system vertically obtains sin 35. Remember that cosine is the horizontal component and sine is for the vertical component. 32 sine 35 plus 21 sine 47 equal to Q sine 65. As you can see, we have projected all the forces vertically. Now that we have written the two equations to resolve the system, we can find the individual values of P and Q. And from this system of equations, we can easily obtain that Q equals to 37.2 and P equals to 27.6. You just have to input the values in the equation into your calculator correctly to be able to obtain this. For this kind of question, you should note that the sum of the forces in all the directions must be 0, which means that when you do this, all the forces must be equated to each other, the forces that are positive and the forces that of magnitude that are negative. And this way we can form a system of equations to solve for P and Q. Right. Now moving on, question number 2. Alright, so question number 2, for this we will be using what are called the Suva equations, because as you can see, the acceleration is uniform, which means that in this question you should use Suva. Right. The graph for this will look like this. It starts at 0. It travels in a straight line, like so. Right. It accelerates to reach a speed of v. So if this is your v, this is your v, and then the athlete maintains this speed, right? So the speed is constant, and then they decelerate back to rest. So this is part 1. This is when it's accelerating. This is part 2 with constant speed, and this is part 3. Right. Find c in terms of v. Well, for this, if you notice, for part 1, using v equals to u plus at on part 1, The initial speed is 0. The final speed is capital V. Right. It says that the athlete starts from rest and accelerates at 0.5 meters per second squared. It accelerates at 0.5 meters per second squared. So A is 0.5. T. Fine. T. So the time taken is V divided by 0.5, which gives 2V. That's something for the first part, right? So that's something for the first part. And then for the second part, we can, again using a V equals U plus AT. Well, your final speed is 0, your initial speed is V. Your acceleration is minus 0.2 T. 0.2 times your time T. So your V so your T is V divided by 0.2, and this will yield 5V. So for the times when the athlete is moving not at a constant speed, the total time taken is 7V, and the athlete moves at a constant speed for capital T seconds. And the entire journey takes 246 seconds. Means that 7V plus T is equal to 246. Right. And so T in terms of V is 246 minus 7V. Hence, show that 7V squared minus 492V plus 2700 is 0. Well, essentially, that is T Well, essentially for this, we use the area under the graph to we use the area under the graph, the area of the trapezium, to find to find the value of V based on the graph. So this is your two parallel sides. V is your height. You divide by 2, and this is 1,350, and expanding and simplifying the whole thing will give you 7V squared minus 492V plus 2700 equals 0. Expanding and simplifying this entire expression will yield this result. Yep. This simplification is a task left to you, the viewer, to try show this result on your own. Last one. So find the value of v. We factorize this. This would yield, to solve the quadratic equation, there are two solutions, but this is rejected. We reject that because if that isn't time taken, if that is your time taken, then substituting this into your expression for t would yield 246 minus 7 times this, which is minus 450. Yeah, the solution would be 450 over 7, right? Instead of 450, this is less than 0, and time cannot be less than 0. That is why we would reject that solution. Right. Okay, moving on. Number 3. A car is moving on a straight road. Right. And here they give us two cases. This is case 1. And this is case number 2. Right. Yeah, this is case number 2. In case 1, just because the car is moving at a constant speed, so the sum of forces, the resultant sum of forces is 0. And so the resistance force is equal to the driving force by the engine. And so since P is equal to FV, right? F is your R, because the car is clearly moving at constant speed. So your resistance force and driving force are equal, times the constant speed of 20. This is your power. For case 2, if we were to draw the free body diagram for this, if we were to draw the diagram, this is your angle theta. You have the car like this. The car moves up. What are the forces counteracting this motion up? They are the component of weight parallel to the slope and the resistance force. So f is equal to, mg sin theta plus r. M is 800, it's given, right? G is 10 in this case. Sin theta is 0.15. What is your R? Your R is what you want to find. Your F, well, you can use P. P equals FV, so F is P over V. What is your V? V is 12. This is your V, so P over 12. And so this boils down into a Simult equations problem. So this is equation 1, this is equation 2. P, substituting P is 20R into this, we get 5R over 3 is equal to 1200 plus R. So from here we should be able to get that R is 1800, and so P is 20 times R, so P is 36 times. What? Find that straight from the car. Now we have to find that straight from the car, but it's moving at 10 meters per second up the inclined section of the road. Well, it's the same inclined section as the one earlier, right? Yep. Well, first off, we use P equals FV to find the driving force from the engine. Yeah, we use the P from the previous result to get 3200. This is your F, and your driving force minus your R minus your component of weight, which again is 1200, is the resultant force, which is MA. On the left hand side it's 200. On the right hand side, what is your M? 800. 8 times A. So A is 0.25 meter per second. Right, next. Okay, given, right. So P moves in a straight line. A, this is the expression for A, right? So first things first, we can integrate this. Yeah, at t equals 0, P equals 1. So your constant of integration is 1. Yep. P is never at instantaneous rest. Yeah. A A is always greater than 0. A is always greater than 0 because P is never at rest. So A must always be increasing. Right. So then V is also always increasing. So V is always increasing. V is always increasing, which means that this is always greater than 0. Which means that essentially now we know that this is always greater than 0. How do we ensure that it is always greater than 0? To make the discriminant always positive. And so 9 minus 2k is always greater than 0. And so case and so the critical value is 4.5, right? Yeah, the critical value for k to always be positive is 4.5. And hence k must be larger than this value. Given instead that k is 2.5, find the total in distance. Right. Let me just rewrite the acceleration expression now that we know k is 2.5. So this is the information we're given. Right. They want distance, so we need to integrate velocity to get distance, which will yield 1/6 kt cubed minus 3/2 t squared plus c. Essentially, that is a follow through on. Essentially, that expression is a natural follow through on this. Alright. So that's your displacement. We know that A is 2.5. We know that this value is 2.5 for part B. K is 2.5. So in putting 2.5 into your K, you will yield is the expression for S. So then you might think that we can just do this and so evaluate this guy from x equals to 3 to x equals to 1. You may think you can do this. You cannot. Why can't you do this? What is the reason? That's because when you substitute 2.5 into your v, right, where you will get this equation, right? As you can already probably see, this smells very fishy because it's a quadratic. Of course, we have to check for the presence of an instant that p is instantaneously at rest. We need to check for a moment that p is instantaneously at rest. Oh, there is. P is instantaneously at rest at t is 0.4 and t is 2. So we need to find the values of s at t equals 1, t equals 2, t equals 3, and calculate this part of the journey and this part of the journey separately. This is, at this point it's minus 1 over 12, and this one's minus 2 over 3, and at this point it's 3 over 4, which is exactly the whole point. There is a reversing of the sign. So essentially the particle moves like this and then like this. Right. So that means the total displacement, evaluating both journeys together, yields exactly 2. Okay, number 5. Alright, so this is a classic connected particles question. It's a very, very classic connected particles style question. So we have 3 particles PQR. Both strings are taut. The system is released from rest. Well, the system is released from rest. What happens? Well, the system will fall towards the direction of the heaviest particle at the end of the string, which means it will fall like this, right? The direction of motion of the entire system PQR will go like that. Like that. With Q, right, with Q we can observe that with Q and R, right, there are there are two particles that we can analyze, right? Yeah, this the tension is double, right? So this is 2T and this is 2T and this is T and this is T. So for now we can ignore P. We can ignore P because the acceleration of P, Q, R are all the same. So we ignore P for the moment. You focus on Q and R. Q. It will fall with Q. Gravity wins because Q is heavier, right? Gravity wins. So Q falls down. So 5G minus 2T equals to 5A. This is Newton's second law. This is a basic application of Newton's second law. R. With R, what happens? Tension wins. Because R will move like this. Right. R will move like that. R moves up. So T minus 2G is equal to 2A. And that's your second equation. Solving these two equations in terms of G yields T equal to 20 over 9 G. So that means that in the tension in this string is 40 over 9G and the tension in this string is 20 over 9G. And your A is 1 over 9G. This leads to the follow-up question. Find the coefficient of friction between P and A. And now we consider the motion of P. P moves downwards. Right? Yeah, P moves downwards. So the sum of the forces acting on P, sum of all the tension, there's a sum of all the tensions, all the friction, all the weight will be equal to MA. Right. With MA, which allows us to construct the following equation. We know that M is 6. And we know that theta is 30 degrees. So sin theta is half plus T minus mu is what we want to find, remember? M is 6 times G cos theta is square root 3 over 2 cos 30 is equal to MA 6A. What is A? A is found already as 1 over 9G, right? Yeah. Now we just need to Now just let's solve this. At this point, we can use G as 10 to obtain that 30 plus T minus 6 60 times square root 3 over 2, so 30 square root. Three mu is equal to 20. G is 10. 6 over 9 is 2 over 3 times 10. 20 over 3. T is itself 20 over 9G. Right. So T is 200 over 9 minus T square root 3 equals 20 over 3. Now we have an equation in terms of a linear equation in terms of mu only. Right, we move this here, right? So move this guy here, right? No, first we can divide everything by 10 just to make life a bit easier. And then we can move this here, and we can move this there. This side of the equation would evaluate to 41 over 9 equals, and that is equal to 3 squared 3 mu, right? So we divide this entire thing over there. Zero mu. You can simplify this into exact form, of course. So 41 squared 3 over 81. Or for a decimal answer, this would yield 0.8767. Nice. For part C, part C uses the idea of SUVAT actually. Because you want to find the time needed for P to get to this point. Right. Right. Yes. And so we write that S is UT plus half AT squared, which is the distance traveled by P. S is the distance traveled is half of the length of the plane, because P is origin at the midpoint, and this is equal to, well, P is released from rest, right? We know that half times, what is A? A is 1 over 9G, right? We found that earlier. And it took P 1.5 seconds squared. So L over 2 is, well, if we evaluate the whole thing, alright, so we can cancel this out first. So L is 1.5 squared over 9 times G, and this is 2.25 divided by 9, so 0.25 G, or you may also write this as 2.5 meters. Yeah, final answer. Alright, last question. Whew. This is one heck of a difficult one. Let's walk through this one slowly, bit by bit. Right, so we have two particles. This is A, this is B. Right, so A has mass km, B has mass m. A moves at speed 2u, and B moves with speed u. Okay. By momentum, we can say that alright, this is gonna be a lot more. Bear with me. By momentum, we can say that 2u times km m1 plus m times minus u equals to ku times m. Let's call this v of b. Well, first things first, we can get rid of m on everything. Minus u equals to ku is v of b. So then v of b is equal to u minus u. That is your momentum conservation. And now take a look at the energy lost. This entire thing is essentially kinetic energy all the way. Right, so half mv squared, right? That means squared, by the way, that means squared, plus half m u squared equal to right, so this is your the initial init for initial. Yeah, this is your initial kinetic energy. Simplifying this gives you squared KE final. This is your final kinetic energy, is half am u squared plus half m V of B is KU minus U squared. And this will be equal to half U squared plus, and this is equal to half KMB squared plus half M A squared U squared plus 2KU squared plus U squared. And this simplifies to minus half KMU squared plus half E squared U squared of just use brackets here so no one gets confused. Same here. Yeah, I'll just use inner curve brackets so no one gets confused. Because this is already, because this is getting very, very complicated. The algebra here is already starting to get very, very complicated. So to solve this, use brackets on everything. That is here. Plus half U squared. Okay, so KE in it times 0.65, just 35, because it says 35% of total energy loss. So that is the remaining amount of energy. That's the remaining amount of energy after the collision. It goes to KE final. So by cross multiplying, we can get rid of the decimal, right? Because 0.65 is 65 divided by 100. This way we can make the expression a bit neater. This way we can make the expression a bit neater. Right. That's the final kinetic energy. Right, that's the final kinetic energy. We can divide everything by mu squared. At this point we can divide by mu squared. E squared plus 50. And that will simplify very neatly. Okay. Well, E squared minus 180. Okay. Plus 35. And now we get a quadratic in K, which we can get multiply everything to get rid of the get rid of the fraction. This simplifies 20k squared minus 72k plus 7 equal to 0. Oh wait, yeah, this is 35. Yeah, 100k squared minus 3k was 35 equals 0. That simplifies this because we divide everything by 5. So you got 10k minus 1, 2k minus 7 equals to 0. Well, so k is 0.1 or k is 3.5. But we reject. We have to reject 0.1. Why? We reject 0.1. Question says that both particles move in the same direction. And if we substitute 0.1 into v of b, we get negative velocity. Remember that our sign convention was this is positive, this is negative, which means that it is impossible for 0.1 because that would imply b is moving here, which is physically impossible. So k is 3.5. And so v of b is 3.5k. K equal to 2.5. Yeah. So v of b is 3.5 minus 1 is so b is 2.5. There we go. And that is 8 marks. And that is 8 marks. What a question. Whew. Alright. And that completes the discussion of this paper. Yep. Please check out the mark scheme and the question paper in the pinned comment. Hope all of you will get good for tomorrow. And wish you all the best for all of your time trials and prelims. See you next time.